Hello students, in today's video we are going to discuss standard forms of Boolean expression. So first we will see why we need to standardize our Boolean expression. Basically, standardization makes the evaluation, simplification and implementation of Boolean expressions much more systematic and easier. We have two ways to standardize our Boolean expression. They can be either converted into the sum of product or the product of sums form. In today's video, we will see what do we mean by the sum of product form. The sum of product expressions can be implemented with one or and two or more AND gates. A product term consists of the product of variables or their complements. When two or more product terms are summed by Boolean addition, the resulting expression is a sum of products. We have some examples of sum of products. Like our first example here is A complement B or C. This expression basically consists of two terms. One term is the product term with A complement and B, and the next term we have C, and in between them there is one OR operation. Next we have A and B and C or A and B. That means we are having two terms in which we have one term as A and B and C, and next term as A and C, and in between these two terms we are having the sum operation. Then next we have A and B and C complement, or A and B or B and C complement. So all these terms are the product terms, and in between these product terms we have the sum operation, or we can say the OR operation. So these are just the examples of sum of products form. If we want to implement the SOP expression, we can implement this expression by using just one OR gate, and we can have the number of AND gates, and the number of AND gates totally depends upon the number of product terms involved or number of product terms present in the expression. So you can see that implementing an SOP expression simply requires ORing the output of two or more AND gates. So in this diagram, I have basically taken the three variables, and the function on these three variables is actually the sum of product expression. If you will see, we have A and B and C, or A and B complement and C, or A and C. So this expression or this function is actually in the form of sum of product, because we are having the product terms which are combined or joined together by the OR operation. So when we make a circuit for the original expression, you can see that we are having just one OR gate that has been applied at the final function, and in between we are having the number of AND gates. AND gates are basically used for the product terms. Now we have A, B and C. A, B, C are the input variables in which we have the connection to A given to all the three AND gates, the connection of B given to the first term, and the complement of B, wherein we have taken the NOT gate here. So we are taking the complement of B in the second term, and then in the third term we are taking the connection of A and C, and ultimately we are just applying the OR gate here. So that means implementing any SOP expression simply requires just one OR gate, and then we can have the number of AND gates, which depends upon the number of product terms involved. So now, conversion of general expression to SOP. We can convert any logical expression into SOP by applying just simple Boolean algebraic techniques. If you see here in this example, we have an example like A and B or C. So we can just write it as A and B or A and C, just applying the distributive law. And the expression which we have got after applying the distributive law is in the form of SOP. So now in today's video we will just take certain examples and we will try to convert them in SOP. Okay, so let's take these examples and we will try to convert the following Boolean expressions to SOP forms. So our first example is A and B, or B and C and D, or E and F. So now we have to convert it into the sum of product form. Now we can simplify it, just we can write it as, like, it can be taken as A and B, as A and B is already in the sum of product, it's a product term. Then we can apply just the distributive law. Then we can say B and C and D, or B and E and F. So now if you will see this expression is basically now in the sum of product form, because these are our product terms and they are summed by this OR operator. Now again we have another example wherein we have A or B whole complement, or C, again the whole complement on this expression. Now first we will try to apply here De Morgan's theorem. We will apply the De Morgan's theorem first on the outer complement. So if you remember that in De Morgan's theorem, A or B whole complement is equal to A complement and B complement. So if in this expression we will take A or B as a single term, then we can just write it as A or B complement, it has a complement, then another complement after applying the Boolean, after applying the De Morgan's theorem. Then we have and C complement. So now this will be again equal to, if you remember, we have a law in Boolean algebra wherein we say whenever we have the double complement on a variable, that is always equal to the variable. So if we will take this a or b as a single variable, as a term here, we are having the double complement on it. So we can just simply say that this is equal to a, this will be equal to a or b and c complement. Now we have this, we have to convert it into the SOP form. So we will simply now apply the distributive law. After applying the distributive law, it will be equal to a c complement or b c complement. So if you will see this final term which we got, this is basically in the SOP form, because we are having the product term as A and C complement or B and C complement. So hope the video was helpful to you. Thank you for watching it.